Name your character in a very specific way. Talk to this one NPC, the old man in Viridian City. Then fly to this exact destination, Cinnabar Island. And finally, surf along this tiny strip of coastline. Suddenly, a wild encounter with a mess of pixels. Somehow, you get 128 additional units of the 6th item in your inventory. Parts of the game get corrupted, but it keeps running just fine. You can even catch this thing. A normal/bird type Pokémon, with not one but 2 copies of Water Gun. The MissingNo glitch was one of the most iconic bugs in video game history. But why do these exact steps trigger it? How does all of it actually happen? At the very beginning of the game, the player meets an old man who teaches them how to catch Pokémon. This tutorial is actually a scripted battle, and to make it work, the game briefly swaps out your character and puts you in control of the NPC. To do this, it temporarily overwrites the player's name with the not-so-creative name of this other character, Old Man. Naturally, the original name needs to be restored afterwards, so the game saves it somewhere else in memory. Unfortunately, the Game Boy had extremely limited memory, and although the Pokémon games had what are called reserved memory addresses for different game features, such as records of the gym badges the player has or the set of Pokémon moves used to interact with the environment, these regions were often shared and reused by different functionalities, interpreting the sequence of zeros and ones in multiple ways depending on the context. In this case, the player's name gets saved into a chunk of memory that's also used under different circumstances to define which wild Pokémon can appear in the current area. The developers had to pick a location in memory that wouldn't cause trouble during this tutorial, and the address tied to the Wild Encounters table seemed safe, since the old man is standing inside the walls of Viridian City, where wild battles aren't supposed to happen at all. It made sense at the time, but as we'll see, it didn't quite work out that way. After talking with the old man, we fly to Cinnabar Island from Viridian City and surf up and down along the very edge of the east coast. The moment we jump into the water, we enter wild Pokémon territory, which triggers the game to update the list of possible encounters. Water Pokémon have their own section within this list, and it doesn't overlap with the memory address where our character's name is still stored, so that data simply remains there. This shouldn't be a problem. The section containing land-based encounters isn't supposed to be relevant when we are surfing. And that's true everywhere except here, on this specific strip of coastline. It turns out these water tiles are misconfigured. They are marked as lands for the purpose of wild encounters. So if we run into Pokémon here, the game will actually read from the list of possible land encounters, which still contains our character's name, never overwritten with valid data. The game doesn't realize anything is off. What we've been showing as nicely formatted information in these diagrams is, in practice, just a series of zeros and ones. What those bits represent depends entirely on the context. In this case, the game is expecting to find a list of wild Pokémon. Each entry in that list is defined by a Pokémon's level and an internal identifier, both stored as numbers. For example, Pikachu is represented by the ID 84, just an arbitrary value in the code. But now some of those values come from our character's name. Since the game doesn't know these values were originally meant to be letters, it interprets them as Pokémon IDs and levels, generating unique and extremely random encounters, depending on the exact characters we chose. For example, if we pick the silly but very deliberate name Big Boss without spaces, the 4th and 5th characters, the letters B and O, can produce a level 129 Clefable to appear along this shore. The game uses the internal ID of the Pokémon to fetch some of its properties, including its name and Pokédex number. This mapping includes entries for all 151 original Pokémon, but also a number of unused slots. During development, the programmers seem to have experimented with additional Pokémon that were ultimately scraped, and although their data was wiped, the slots were never removed. Instead, their entries were overwritten with placeholder values, a Pokédex number of 0 to indicate a missing number, and the name MissingNo. These MissingNo entries should never be accessed, but thanks to the old man and the broken coastline of Cinnabar Islands, the game can attempt to load any ID from the table, including those. In the case of Big Boss, we end up with 2 different MissingNos, at levels 136 and 146. According to a leaked prototype of Pokémon Blue, one of them was originally a pre-evolution of Meowth and the other an evolution of Marowak. But in the final game they appear identical, because they both share the placeholder Pokédex number 0, which the game uses to load further properties, such as their attack moves and their Sprite. Before we get into that, it's worth mentioning that finding MissingNo has an unexpected side effect. Simply triggering the encounter is enough to increase the quantity of the item in the 6th slot of the backpack by 128 units. Players often place their Master Balls or rare candies there, duplicating valuable items this way. But why does this happen? The game maintains a list of binary values, one for each Pokémon, indicating whether it has been seen at least once. This is used by the Pokédex mechanic. A 1 in this list means a Pokémon was already discovered, and a 0 means it's yet to be found. The position in this list is determined by the Pokémon's Pokédex number. For example, Bulbasaur is the first Pokémon in the Pokédex, so it maps to the first position. Charmander is in the 4th spot and Squirtle in the 7th. However, there's a small catch. It's common in programming to start counting from 0, not from 1. For this reason, the game subtracts 1 from the Pokédex number to find the corresponding position. Bulbasaur, with Pokédex ID 1, ends up in position 0, Charmander in slot 3 and Squirtle in 6. This is where the problem begins. MissingNo was assigned a Pokédex number of 0. Subtracting 1 gives us -1, which isn't a valid index. In this context, the number wraps around, and the system instead accesses position 255, a value that often appears as an upper limit in systems like the Game Boy. This number is well out of bounds, considering only 151 Pokémon were actually released in the game. But the code doesn't notice, and writes a very sneaky number 1 far beyond the memory reserved for the Pokédex. Luckily for kids in the 90s, right after the Pokédex data in memory, we find information related to the inventory. Items in the bag are stored as a list of pairs. Each item has an ID and a quantity, similar to how wild encounters are defined by level and Pokémon ID. And it turns out the bit flipped by the game while trying to mark MissingNo as discovered actually belongs to the binary representation of the quantity for item number 6. Setting that bit from 0 to 1 has the same effect as adding 128 to the total. That's how this blob of pixels ends up triggering a chain of very lucky coincidences that result in virtually infinite supplies. What about those pixels though? A Pokémon's graphics are selected based on its Pokédex ID. This table includes a value indicating the size of the image, since not all Pokémon occupy the full area of the battle portrait, along with a reference to a memory address containing the actual sprite data. The problem is that the values associated with Pokédex ID 0, MissingNo's entry, are essentially garbage. This entry was never meant to be used. Still, the game tries to interpret the data anyway, and the result is a mess of pixels on the screen. That invalid reference to the graphics data happens to point to a memory location containing game logic. Since code is fixed in memory and never changes, MissingNo always appears the same, a glitchy block of tiny squares. It's arbitrary, but also consistent. There's also a second consequence tied to the size value. For MissingNo, this number is far larger than what a standard Pokémon portrait requires. The rendering routine simply accepts the value and continues writing graphical data well beyond the allocated area. Unfortunately, the overwritten memory holds the Hall of Fame records, a log of the player's achievements after completing the game. After encountering MissingNo, this data becomes fully corrupted. That's the only lasting damage caused by our otherwise harmless pixelated friend. MissingNo was meant to be a silent patch for forgotten Pokémon, never meant to be seen. But a handful of quiet technical mistakes turned it into a legend passed between players in the 90s, and into one of the most iconic bags in gaming history. See you next time.